Hi, I'm Curran, and this is one way you can solve the map labeling problem. Here's the before picture with all these overlapping labels, and here's what it looks like after we implemented this label filtering algorithm. Render each one by one, and if it intersects with any other labels that are already there, then don't draw it. And then the question is, how do we know which labels it intersects with that are already there? In this live coding session, we'll touch upon using the R-tree spatial index via RBush.js, measuring bounding boxes of SVG text, iterating over elements in D3 selections, the importance of the key function in D3 data joins and the various kinds of bugs that could be caused if you get it wrong, and finally controlling the Z ordering with DOM ordering in SVGs. And shout out to GC who joined me live.
I have a question for you.
Sure, what's your question?
Yeah, for scatter plot, right? When you attempt to label all the points in a scatter plot, sometimes the text will get overlapping that will make the labels less readable.
Right.
Um,
Well, that is a very serious problem. Thank you for the question. And you know, let me bring up this other example where I actually ran into this problem. So I made this map here that shows population density across the world, and it's zoomable. And it's essentially the same problem as labeling a scatter plot because I'm labeling points. And see, we've got labels for like New York and Chicago. And the way this works is it just filters by a certain threshold of population. But it doesn't work as well as I'd like it to. And so I actually had this idea for a labeling algorithm. Well, in general, I think there would be some prioritization because you have to figure out what points do I want to prioritize labeling, because you're not going to be able to label all the points, I don't think, unless you have like lines going off to the edge,
yeah, agree.
which you might
I guess
have.
sometimes even maybe that can be made as a user option.
Yeah, I mean, sometimes it can be too much, and I think maybe the best solution might be to label some of the points such that you can read the labels as opposed to labeling all the points, in which case you wouldn't be able to read all the labels because they would overlap or the text would be too small. Actually, this would be a fun one to work on. Label placement algorithm. How would that look? I think this is where it's rendering the labels. Yeah, so it's got these labels here. It just sort of puts them all on the screen at once. But what we want to do instead is like render each one by one, and if it intersects with any other labels that are already there, then don't draw it. And then the question is, how do we know which labels it intersects with that are already there? And for that, I was thinking to use this R-tree library called RBush, which is a spatial index. Yeah, RBush. So this is an example, a proof of concept I made for contours on a map with panning and zooming. But it uses RBush internally. I'm just going to leverage the configuration of this and copy it over here to our package.json. So I could say, all right, now we are also using RBush, and I'm going to add it as a dependency. And now we should be able to import from RBush like this. So I guess I'll add this into map.js. And then I'll just console log it to see if the import worked. And there it is. There's RBush. Excellent, excellent. So how do we run it? How do we use RBush? Let me just search in this other example how it's instantiated. We create a new tree, RBush, and I'll do that down here. And then how do we add the bounding boxes? So we can call tree.load items on an array of objects that have these properties: min x, min y, max x, max y, and I think feature was something custom. And so let's just change this around to compute this from our bounding boxes. We could say bounding boxes dot map bounding box, and then min x is going to be bounding box dot. Okay, it's got x, y, width, and height. Great. So min x is bounding box dot x. Min y is bounding box dot y, and then max x is, well, we're going to have to compute this as bounding box dot x plus bounding box dot width. Pretty sure. And then for the last one, let me give AI a shot. There we go. Now, okay, let me take a step back here. This is how you index all of the things at once, but that's not actually what we want to do, right? Because the algorithm I had in mind was for each city sorted by population descending, add that label to the R tree. Before adding it to the R tree, we want to query the R tree and say, yo, does this label that we're about to add collide with any of the existing labels that are already there? If not, then we go ahead and add it, and we keep track of that so we can render it. But if it does, then we don't want to render that label, and we don't want to index it into our spatial index either. So I don't think this tree load items is the right thing. We want to load each item individually. Let me just see the documentation for RBush to see if there's a method where we can just add a single entry at a time. Okay, tree.insert item. We don't even need to map over it necessarily, so let me just do this sort of from first principles here. So here's what I want to do. For const bounding box of bounding boxes. All right, simple, old school for loop. And then we're going to want to keep track of which labels to render. So I'll maybe make a new thing called labels to render. But you know what? We sort of, when we just get the bounding box, we lose the information. So I think I want to move this call to get bbox into this loop and then iterate over the nodes. And so I'll say const label text nodes is selection.select all text dot nodes, and then that's what we iterate over. And then we can say bbox is node to get bbox. However, I think we might need to do the each, the for each, the dot selection dot each, because what I want to do, I guess, is isolate the these Ds, these data rows, and have an array of the things that we should render labels for when we're done with all this. So maybe this coming back full circle is what we need. Dot each. That way we can get access to D and also get access to this dot get bbox. But let me sort of separate this from the rendering. So this is labels. Let me assign this to something. Then we want to call labels.each. This will get us access to the datum and also the bounding box. But before we do all that, we want to set up these things, the tree and the labels to render. Now, filtered cities. Let me call this actually cities to render, just so it's sort of in line with the existing code there. All right. That's a lot of figuring out how to start. But then we're going to want the bounding box as, I'll call it bbox. It'll be this.bbox. So just as a sanity check, I'm going to run this and I'm going to add some console.logs. I just want to make sure, like, are we getting the datum and are we getting the bounding box? We need both of those. Those are our ingredients. So I'll console log bbox and D and run it. Let's see what we get. All right, we got all these objects where the bbox is there and the datum is there. Okay, great. Great. And so now the overall structure is going to be if should render this city or this label, which we don't have. That's what we need to figure out. But if we should render it, then we want to add d to cities.render. So cities.render, cities.render.push d, right? So this is coming together. Now all we have to do is figure out if we should render this city. And for that, we need to use our spatial index. And so it should render this label if the query to the R tree returns some value. Or no, if it does not return any value, that conflicts. How do we, okay, search, tree.search, tree.search. This one will return an array of data items that the given bounding box intersects. This intersection is what we're after with the labels, right? Because if the label box intersects, we don't want to draw it. We don't want to draw it at all. What I'm going to do is tree.search. And again, we need that min, this thing here, this mapping from the bounding box to the data structure expected by RBush. And so I'll call this something like search rect or rect for RBush. I don't know what to say. And I do like the longer name bounding box, actually. And so now we've got our search rect, and we should be able to pass the search rect into tree.search and get some result. And then we should render this label if there are no results, meaning if there are no intersecting rectangles. So I think we can do result.length is 0. And so this should run, but it will still render all the labels because we're not actually adding anything to the spatial index. So let's do that. And then we may actually solve this problem and get it to totally run. So if we should render this label, then we push it to cities to render, and then we also index it in the R tree. And that was what? Tree.insert item. And you know, just for consistency with the docs, and I'll add a link to the docs here in the code. They call it item, so I think I will also call it item right here. So we search for that item. If it doesn't overlap, then we want to add that item to the tree. And what was that? Tree.insert item. So now it should work. But how do we know that would work? I'm going to log cities to render.length, and I'm also going to log filtered cities.length. And these should be, you know, if it worked, these should be different numbers, and the cities to render should be a lot lower than filtered cities. So let's run it and see. All right, it ran, and they're different numbers. Yo, look at that. So let me now add some logic that will go back and remove the labels that are not in cities to render. Now we already have a D3 selection. Well, actually, what did we do here? There's a group element that's the parent, and then in that group element we're selecting all text. So actually what I think might be the easiest way to do it here would be to do this same kind of a thing, like .select all text and then .data cities to render. And to do that, we need to get access to this group element that's the parent. So I think I'll make a new variable. I'll call it labels g, and that will be selection.selectAllG.labels and all these attributes. And then after that is set up, we're going to call select all on that. And then after all this is said and done, we want to update the text elements so that they only contain cities to render. So I think we can just do labels g.selectAllText.data cities to render .join text. Would that work? Would that remove the old ones? Yes. Oh my gosh. No, I mean, we still get all these overlapping ones. You know what? Why did it seem to work though? Like, if we look at the US, yeah, it didn't work. It didn't work at all. It totally didn't work.
Oh, I think the data, there's an optional argument called ID, right? Maybe if ID all the data, then.
Yeah, that's a great idea. Let me see what I could use as the ID. That's probably it. So if I log one of these, let's see, what can I use as the ID? City. It's got a name, city. All right, so let's use the key function as d.city over here, and also in the previous one too. When we render all of them, let's set up the key function like that. Yo, I think that's it. Look at these labels.
Awesome.
Wow. Oh, wow, I think it worked. Look at these labels. Wow. Well, there is an
There's still some
overlap.
overlap.
There's still an overlap. Why is there still an overlap? Well, it's much better. It's much better. This right here is the code where we figure out the B box. I wonder if there might be something wrong with this calculation. You know what? Maybe we could just render rectangles on top of the text and see if it lines up. Yeah, just as a test. So items dot push item. And then just to see what's going on, label g.select all rect dot data items. See if the AI could figure out what to do next. Yeah, that looks about right. Let me pull down the stroke width. Oh, this is adding for all of them. Let me get a slightly different view where I will only push this item if we should render this label. So now when it runs, it should just outline the ones that are rendered. And it does. And there's an... What the heck is going on here? There's no outline around that text that's overlapping. There are some cities where the label's being rendered, but the bounding box is not. See that? So what the
Or
heck?
is there a clash with the IDs?
A clash with the IDs, maybe.
Yeah, same city names.
Are there multiple cities with the same name, potentially?
Yeah,
Yeah. Yeah, you know, that could be it. Yeah, that would
and,
explain this.
and yeah, I think this is the only one.
That's a great idea. All right, well, let's give all the cities unique IDs. After we load the data, let's just assign an ID as, I don't know, a random number, or maybe an auto-incrementing number. I wonder, do we get I in this function? We just assign it to the index. So if I console.log I, yeah, okay, 42,000. So there's 42,000 cities there. Now they each have a property called ID, which we know is guaranteed to be unique. So now let's go, yeah, the great insight. Great insight, thank you for that. Now let's go and update the ID function to be d.id. There, and there's their second place, d.id. Okay, let's see if that worked.
Yeah.
Wow, beautiful. Beautiful, it worked. It worked.
Yeah, cool.
Wow. Wow, this is a much more readable map. And then I'm just going to take a look around because I want to study this map. I mean, I really wanted to do this, and thank you for this inspiration to get this done, your question. Thanks for asking the question, because I really wanted to do this so that I could just study this map and see, like, what are the population centers, you know? So on the East Coast, we got New York, Boston, Washington. And there's the answer to my earlier question. What is that big one? It's Atlanta. There we go. Atlanta, Chicago, Minneapolis, and Wisconsin. There's Milwaukee there. And, you know, now that I see this, I kind of want to tweak the density. Let's make it 3. Yeah. So that changes it a little bit. What if I make it 2? So this is changing the calculation, like how blurred it is. Let's see if I bring it way up to like 10. What do we see? Yeah, that's like too broad. Bandwidth of 3 looks pretty good. Okay, cool. So so New York is huge. Los Angeles is huge. And then we've got Chicago, Toronto, Detroit, Atlanta, and then Miami. I mean, Florida's pretty packed. Look at that. And then if we see the rest of the world, wow, Mexico City. That's like huge. It's on the same level of New York City. And then what have we got here? Guatemala City, Bogota. So we got Bogota, Lima, and then, wow, I didn't realize there was such low population density in the middle. And then Sao Paulo. And then what? Buenos Aires. How do you say it? Buenos Aires. Santiago. And then what do we got in Africa for population centers? Johannesburg, Kinshasa, and Lagos. And there's really not that, huh? And Khartoum. Population density is really low throughout the whole, huge portion of the continent. Well, I guess that's a big desert. And then we've got what? Cairo, Istanbul, Tehran, Riyadh, Casablanca. And then in Europe, it's really centered around London and Paris. And then there's Istanbul, Moscow, and yeah, this really helps with this part of the world over here. The India map is looking great. We got Delhi, Mumbai, Kolkata, Bangalore, Hyderabad. Nagpur is actually tiny in comparison. See, I used to live near Nagpur, and I thought it was a big city at 2 million roughly, but it's tiny compared to these other big cities. And then China. This is what made me want to do this algorithm in the first place, because this area is so dense, so dense. It's insanely dense. Looks like there's
I
some
just
weird.
one. Oh yeah, I think that one of the contour is covering up the labels.
Yeah, isn't that funny? Huh. Well, it's probably because I was messing around with the settings.
In SVG, do we have something like a Z order?
Yes. Yeah, in SVG, the Z ordering is determined by the ordering of the elements in the DOM. And the way that this code is structured, it just puts everything on the top level selection, which could be a group element or an SVG element. And to solve this problem, we would probably want to set up group elements as like layers, just for the z-index layering. Because right now it just does this. Well, this is the map stuff. That's not a problem. The problem is the contours. It just does this selection on paths directly on the parent selection. And so what could happen is if a contour is added as I'm tweaking the settings, this join will actually add it on top of the labels. And so one way to solve this is to introduce a parent group element for all the contours. That way we can add and remove the contours within that group element, but because it's inside of a group element and that group element comes before the text labels in the DOM, then we wouldn't have this problem of the contours coming on top of the text. Yeah, something like this. See, we're already doing it for the labels where there's a parent group element, and this was so that I could set all the text properties once and have it get inherited. But let's solve that problem. I mean, that shouldn't be happening. Here it is. I'm going to paste that and say g.contours. And this will be contours g. And so I'll just drop a little comment like this g element is to control z. I'll say z index. It's not z index is kind of a loaded term. Z index from CSS does not work in SVG. So I don't want to call it z index. I'll just control it the z ordering. And then instead of putting all these paths on the selection, we could just put it on contours g. And you know, this actually allows us to simplify this logic here, because the whole point of this class is to differentiate it from other paths that could be on the same in the same parent element. So we can actually get rid of that contour path, because the only paths that are ever going to be inside of this group element are these contour paths. So let me go in and do what I did before, which is change some of the contour settings. And that was just the bandwidth here. So if I say bandwidth is going to be 2 and run it, we get more granular contours. And then when I switch it back, like we don't get that overlapping problem anymore, because now all the contours are like contained in that group element. So yeah, to answer your question, that's one way you can do it. But yeah, basically, this works really well, and I think we solved the problem. Wow, I can't tell you how long this has been on my to-do list, honestly, because I'm working on this textbook, and like label placement for maps has been definitely on my to-do list, and I've had this algorithm in my head for a while. So thanks for pulling it out of me. Thanks for joining and
Yeah.
hanging out.